Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Sansui R-606. This is a budget receiver that is part of a bigger system, I do believe. And I think when you buy the Sansui system, you get the receiver, you get a tape deck, you get a phonograph, record player, and a set of speakers too, I do believe. I'm not sure, 100% sure on that. But this one came to me along with the turntable. So I'll be featuring the turntable in another episode. It's getting worked on at the moment. But this thing here, I had put this on my listening bench for the last couple of days, and I got to tell you, it was a pretty painful experience listening to this thing. The biggest problem with this is this slide volume control is totally knackered, and we need to do something with that because it really destroys the listening experience when you have one channel that's all distortion, or both channels, or one channel's missing. You can't even get this to work in any acceptable manner. You can't adjust the volume without one channel dropping out. Plus we have other things going on. We have dirty switches. This tape switch here doesn't even latch. This one here doesn't latch very well either. So I think there's some problems. This one doesn't latch. And then we have AM/FM digital tuner. I didn't really get a chance to test it out, but from what I tested, we're not picking up stereo signals. It's picking up stations, but that's about all. You have these soft touch controls here, which are kind of unique. If you want to use phono, you press that one. One thing about this is it has no auxiliary input, so you're forced to use one of the tape inputs for your auxiliary, which is okay. But then every time you turn the machine off, it resets back to one of the tuners, and you want to listen to your auxiliary again, you have to press the button every time you turn the machine on. And it's got some other problems too. We'll get into that in a bit. But aside from that, it seems to be working. So my goal for this is get it going. I also intend to hopefully make some improvements to get better sound out of it. Here on the back, I can show you we got two tape loops. Tape 1, tape 2, phono input, and then that's it. Antenna inputs. We've got two courtesy outlets, one switched, and two sets of speakers. Now this thing does have a STK module as its power output, and it's not very stout because they specify 8 or 16 ohm speakers, and you can't run both speakers at the same time. You got a choice of either A or B. And that's by design, because this is kind of a weak unit. It doesn't really have much good power to drive 4 ohm load. It can't drive a 4 ohm load, and it doesn't have the power to drive two sets of speakers. So you're stuck with one set of speakers. Okay, I'll hook it up to the tone source, and I'll give you a quick demonstration of how badly this thing is operating. Alright, we got this wired into a load, set of speakers, got a tone source, scope's connected, got my second camera going. So let me demonstrate how bad this is, how bad it gets. So watch your ears, this segment might be loud. Let's turn it on. And so everything's good this way. We got about 18 watts consumption as it sits idle. And we need to select tape monitor 1. And this should put us, you hear how bad this volume slider is. Both channels. Let's concentrate on the left channel first. Okay, right channel, same thing. It's worse actually. It's really hard to find a spot where you get the audio coming through. Yeah, this is a really poor design, these sliders. I don't like these. Okay, so let's turn off speakers and we'll put it to the scope. Both channels going here. Let's see if we can get anything on the scope. Channel 1. Channel 2. Okay. So they're both on 500 millivolts division. You can see the distortion. From one channel to the other. So let's take it up. And it's really, really egregious. Okay, so let's clipping. We only have one channel. Yeah. So the big thing here is this volume pot is just horrible. We have to disassemble this and clean this. Now some of these other switches were causing problems. Let's see if we can get a signal on the scope. There's kind of one. This switch here. Let's see when I play with it. Keep losing the left channel. Doesn't fix it. The switch here is we're going to get to that. This is a power switch, but it also has speaker switching built in. Yeah. So I think you get the idea. Take 2. Doesn't latch. Loudness. Doesn't seem to do anything. Okay. Let's test the tuner out while we're here. Hooked up a piece of wire for antenna. FM. We're not getting any stereo. Let's go up and down, and it's not picking up even the strong stations. See, that should, there's a really strong station at 107.9, and we should be picking that up in stereo, and we're not even getting it. It's very weak sounding. So I think this tuner has problems. And let's see, AM, I don't think AM has no antenna, so it's not even bothered with checking. So we have problems. We got, main problem is this volume slider. We got tuner problems, we got switch problems here, and then we got other problems we're going to address. Alright, let's get the cover off this turd. There's a bit of a stain there. I don't know what that's from. But what's going on here? So, what do we have here? I think this here is power supply. Transformer. We have our main switching right here. There's a switch I can see, and the fusing on the side board here. And then there's this, which I think is regulator, power supply. This looks like all power amplifier. We have our SDK module right here. Display, I don't know what this board is. This is FM tuner board here. And then we have another board here which might be the AM tuner. This here is our volume control board. And this might be preamp, I'm not sure. And then it looks like we might have more tuner stuff underneath. Might be our multiplex. And a main board, not really much on it. Yeah, it's pretty sparse. Not many components on the main board. It more looks like it's just an interconnect for the other boards. Up here we got a tone board where our tone controls and balances on this. So that's all up here. Lots of wiring. Here's the bottom. Yeah. That's our power amplifier down here. Main filter caps, so you got 3900 microfarad, 42 volts, just barely adequate. And we got a tiny little transformer. It's so cute. I wonder how many watts this thing pushes. Probably not too many. I'm guessing less than about 20 a channel, or somewhere around there. I haven't really looked it up yet. With a transformer that size, you're not going to get much power through this. The SDK module is an SDK 4843. I can't remember off the top of my head how many watts that is per side. But yeah, it's not big numbers. And with that transformer, we're not going to see a lot of power coming out of this. And we probably have a lot of cracks here on these joints, if I look carefully enough. Looks like somebody might have been already in here touching up joints. But we'll go through it all and we'll make sure it's all 100%. Okay, first line of attack is this volume pot. I'm going to take it out. I don't see any cracked solders on the back, which was kind of what I was thinking might have happened because one channel is cutting in and out so bad. But for the most part, I think it's okay to solder. I'm going to remove this potentiometer slider, and the problem is oxidation got in here and just destroyed this thing. So I'm going to remove this, then we'll take it onto the bench and have a close look at it and clean it up. Okay, so let's get into this. Oh, before I start, take a felt marker, mark one side so that we orientate it the right way. I'll mark this side too so they all face the same direction. Don't know if it matters. Sometimes it does when you open it up and then you find out it's too late after you mixed up all the parts and the orientation. You want to put it back the same way it came apart. So let's just do this. Kind of unusual potentiometer. It's a stereo one. It's 150K times 2. So it would be a little difficult to find one if we needed to replace it. You can buy slider potentiometers. I see them on AliExpress and whatnot. You can get them, but they're not always the configuration you need. Okay, so everything's lifted. This should just pop out. Let's just do this careful. Okay, I think we're, oops. This board is very brittle, so you don't want to flex it because it'll snap like a piece of glass. And then you'll be wondering what to do next. So just be very careful with it. Okay. So we got 4 contacts there. And then we have our, what's going on here. So, okay, this is our problem. Now, not so, that another way. Not so much the carbon tracks. You can see the carbon tracks. There's 2 on each side. They're the black shiny things. And then down the center we have 2. They're not silver anymore, but they should have been silver. So let's just try cleaning with alcohol first. problem with these sliding potentiometers is that they're open to so much junk coming into them. So let's try cleaning this. Wow, look at that. Look at that black stuff. Holy. All right. Let's clean the resistive tracks. These should be a lot cleaner. Okay. Okay. Slowly coming clean. Look at the stuff that's coming off of it though. It's looking a lot better. But I think these two rails here we want to polish because that's where all of our dropouts is happening on that rail. It's not happening on the resistive track. It's happening on the metal-to-metal rail contact from this contact onto the slider. Oxidation is the enemy here. Normally I would polish this with a silver polish, but we're going to try this fiberglass pen. I know a lot of people have been telling me about it, so we're going to try this out. Just going to clean this. It's very light abrasive. It's taking off a lot of black. Maybe this brass. I thought it would be silver plated. Alright, I think that's good. Give it one more cleaning. Just with alcohol. Yeah, that's much better. Okay, I'm going to try something a little different. Today I got some of this stuff. This is fader grease, DFG 213. Now I was reading this, pre-clean surface with deoxit, fader lube to remove surface debris and treat surface. If additional thicker lubrication and protection is required, apply deoxit fader grease DFG 213 to plastic surface. Apply evenly and over entire surface. Contains silicone grease, additives, and no particles. So I don't know why this costs so much. It is very expensive to buy this little tub here. I can't remember, it was quite a bit. And that's really all you need right there. So we're gonna lubricate this slide. And I think for the conductive track we're going to use the green juice F100. And we're just going to put the smallest amount on the resistive track and just let that I need more than that. Let's do this side too. Okay. The problem with using oils or greases in these slides is they attract dust. But you do what you got to do. Okay, this part here, we can clean this as well. Don't bend these. Just want to get the junk off of them. Okay, I think we're ready. There's our marks. One there. Let's give this some lubrication too. Use the same stuff. That's more than enough. Oh yeah, that's going to make a nice. Come on. There we go. Yeah, that faded grease gives it a nice feel. Okay, we are done. Let's close this up. Yeah, much nicer. Okay, back together. Let's give it a quick test. See how it runs now. Turning it on. Tape. It's working better, a lot better. You still have distortion in the left channel, but that could be something else too, like this switch. See that? This might be good. Yeah. On to step 2. I'll show you what I'm talking about. Okay, Sansui put these stupid switches here on the power switch. This is the power switch. You can hear they're running the speaker current through these 2 switches. And you can see as I manipulate the switch, it causes distortion in the right channel and in the left. Both these switches are bad. Now, what those switches are there for, I think, are for speaker muting when you shut the power off. And if that's its only purpose, I'm going to just bypass this garbage, get rid of these switches, because this is causing problems in the circuit. Okay. Actually, you know what I want to do? I want to measure the internal resistance between the output of the amplifier chip and the speaker output in the back. I want to see how many ohms we have. I bet you it's way up there. Okay, pin 5 and 12 are the speaker outputs of the SDK chip. I'm just going to connect an ohm meter between one channel. Tacked a couple wires on here, and I have the speakers set up for being turned on. Turn the power switch on too. It's not plugged in. Okay, I think it's on. Let's connect this. Oh look, we're getting 20 ohms, but that might not be the right channel. Let's see the other channel. No, it's no better. So I think if I manipulate the switch back here, you can see it jumping around. How terrible that is. Let's try the other channel. Shouldn't be any ohm reading between the 2 channels. Okay, turn the speakers off. I get 13K. See how yeah, it's terrible. Just terrible. Yeah, exactly. That's exactly what I thought it was. We're not getting all that resistance between those switches, that between the output of that chip and the back panel connector is just causing havoc with the signal. So we're going to have to do some fixing there. I think we're going to eliminate the switches up front here on the power switch. Let's get rid of that. Let's bypass those completely. I don't know why they're there. Let's go have a look at the schematic. Okay, this may be a little difficult for you to see. There's a lot on here. So here's our SDK chip. This half of it here, half of it's here. Here's pin 5, pin 12. That's our outputs for our speakers. And it goes through out to this connector here. Well, it's a ribbon cable, a 4-conductor. And pin 12 comes up and out this conductor as well. And where does this go? A, B, C, and D. Well, if I go down here it reappears A, B, C, and D. And then it goes into this switch that is connected with the power switch. These 3 switches are all tied together. Well, actually there's 5. But why do we need this? I don't know. It just seems redundant. And one is called unlocked, one is called locked. So A comes up through here, signal through this switch, then through this switch. So it goes through both switches. And then it comes down here and it goes through 2 more switches. This is the these are the speaker switches. The first switch, I think, just turns the speaker switch off so that you only have headphones. The second switch toggles between system A and system B. It's a really odd system. They could have just had one switch for A, one for B. The signal come through, it go through one switch, and then that would be out to the speakers, and then everything's good. But no, they had to do it so that the signal has to go through 2 switches and before it heads out to the speaker. So I would like to rewire this, but if I did rewire this, it wouldn't match what it says on the front panel. So I'll leave this alone. I'm going to eliminate all this. I don't know what purpose it serves. If it's just to prevent a little bit of thump when you turn the power off, who cares? I'd rather have no resistance here than all this garbage, and we'll do that. Alright, did some work and made some big changes. I removed a couple of useless switches. These are gone, and I removed them from this board. And I also removed the, where is it? Also removed the connector for this. That's gone. Gone. It was a stupid idea, Sansui. So I had to glue this. These are 2 pieces. I had to glue them together in order to get this switch to function. And now I have a proper functioning power switch with no other idiocy attached to it. So other things I've been doing. This here is our speaker switch. And I took these 2 switches off, cleaned them. They had pretty high contact resistance, but they're good now. They're about 20 or 16 milliohms, somewhere around there. Another thing I didn't really like about this thing is the ground system. So this 4-pin conductor here comes from the power amplifier. The 2 outside wires are your left and right channel. The 2 inside wires are your grounds for the left and right channel. Now what they did is they ran the grounds along the exact same path as the speaker output. You're actually adding all this resistance in your grounds. So I removed all that. Well, actually what I did is this is a 6 conductor ribbon, and 2 of the conductors were grounds. So I removed those 2 ground wires, and I relocated those wires to carry speaker current instead of ground current. That is because this is like a 24 gauge ribbon cable. Doubling it up improves it quite a bit. And then I'm going to run a dedicated ground to this, to the speaker outlet. And this dedicated ground is going to go right back to the power supply to ground 0, which is the capacitors. So this is all done. This has been bypassed. So this connects here. Speaker current comes in, goes to the switches. Now I have to leave these ground wires in place because the headphone jack needs a ground reference. So I'm going to leave that alone. But the ground is broken between here and here. There is no more ground. And this should now work a lot better. We're going to get a lot better internal resistance is going to be a lot lower, and things are going to improve around here. Now, onto this thing. First off, I pulled these two caps out, these teeny little 3900s. These are measuring, I measured one was 18% down, one was 22% down in value. I'm going to replace both of these. I'm thinking I'm going to put 6800 microfarad. This will give it a good boost in reserve capacity. Another thing is the paste is dry. I'm going to replace all this. I'm also going to replace caps in the power amplifier and in the power supply, this power supply. And we'll see how that goes. And if these caps come out okay, I might just leave the rest of the unit alone. If not, I might replace them all. I don't know. Depends on how this goes. I also have a couple caps here on the tone board, 4 of them anyway. I'll probably replace these ones as well. And then we're going to have to focus on the tuner because the tuner wasn't doing very good. But that's it for now. I'm going to continue replacing these caps and getting this in order. I'm going to make some changes around here. They have, I just shake my head. They have for the power coming off these capacitors, they have it going through a jumper, a trace, a jumper, a trace, a jumper before it hits the SDK chip. So I'm just going to remove those jumpers and just put a wire directly to the chip, a heavy gauge wire, so that it gets the current and it gets the power it needs. And I'm going to go through all these silly jumpers. This is really a poor design by Sansui. This is really, they really sold out on their brand name because of this. They did a lot of things, a lot of shortcuts. Alright, I'll bring you back in when there's more to talk about. Okay, I just finished on this. I did a lot of work. What I did is I recapped the power amplifier, recapped the power supply, I recapped the phono board, and a lot of the other boards like the tuner, the main board here. There's another board here for the tuner, and then a board back here for system control. I pulled them out and I tested caps. I didn't necessarily replace all the caps. I replaced the worst ones. There were actually a lot of bad caps in this thing, and I still have one board to do, which is the tone control board. There's 4 caps I'm going to replace, and then I'm going to treat these pots, even though they didn't exhibit any problems. I'm just going to do that anyways. But I just want to talk a bit about this Sansui. I usually try not to get too negative on a piece of equipment. I try to point out the flaws of its condition, not so much the flaws of its design, but in this case, the flaws of its design were this pathetic speaker arrangement here. They have the wiring coming from the power amplifier, running to the switch, running to the power board, running back to the switch, running to the back output board, and all of that wiring, all of that internal resistance was just it's a bad thing for this, and I eliminated a lot of it. I think I made some improvements. I made some improvements to the power amplifier board. I removed a bunch of power jumpers and just replaced it with a solid wire, and all new caps on that one. Upsized the capacitors. They used barely the size that was adequate for this receiver. These caps are 3900 microfarad for, which is supposed to be a 30 watt per channel receiver, is totally inadequate. And they went really cheap on this. This is part of Sansui's failing right here. This is part of my rant on this Sansui, on how it's junk. They made a bunch of these receivers. It wasn't just the 606. They made a 505. They made a 610, a 611. They made a 707. And I think they made a 411 as well. They're all kind of look the same. They have the same digital tuning, the same 3 controls on the left hand side. They all have the same appearance. They all had that goofy volume slider pot, and they're all based on the same kind of format, and they're all failures, every one of them, in my opinion. I don't know why Sansui did this. They sold out in the 80s and they started making this junk. Now, I don't want to get too critical on Sansui itself. I know a lot of manufacturers did the exact same thing. Pioneer, Marantz, they all did the same thing. They cut costs. They tried to beat their competition by producing a lower cost product, which equates to less build quality, less performance. So hopefully the changes I made to this one will improve performance over what it was. Well, it was unlistenable before because the volume pot was just a joke. And hopefully the changes I made will improve this to the point where it's usable now, and it's going to sound better than when it came out of the factory. That's my goal. So we'll see what we can do here. Like I said, I still have work to do. And we're just about ready to start testing. I still want to go through the tuner and dial that in. I have the service manual here. I'm going to go through and do a quick and dirty alignment, see if anything is off with that. I have a feeling the 19 kilohertz oscillator is off. That's why I'm not getting stereo. That's my guess right now. I'm not confirming that. Some other things I did. I still have to, there's this board here that runs down. It's kind of buried, and it's soldered to the main board here with these three. I need to desolder this board, take it out. There's caps on there too, but there's a microcontroller on there, so I want to make sure those caps are good so that we don't have any glitching. I did remove the display board with the vacuum fluorescent display. You always do that, because if you check on the solder connections for the vacuum fluorescent display, 9 times out of 10 you're going to find cracks on them, on the solder joints. So yes, I did find cracks. I think I found 3 or 4, so I soldered those all up. There was a burned out pilot lamp on here. It was a 6.3 volt incandescent lamp. Let me dig it out here. So there's a 6.3 volt incandescent lamp with a blue condom on it. It's incandescent. And this was burned out. And that was on the display board. And what that does is it illuminates this clear plastic. It kind of makes it glow like a light pipe. And it lights up these 6 buttons. There's 3 on each side. It lights them up, and it lights up the graphics that's inside the window here. And that was out, so I replaced that with the blue LED, which was pretty easy. The original bulb was fed with AC voltage, 2 wires that ran down to the power supply board and came down here and was fed off the transformer. I removed that, put a dropping resistor, and attached it to one of the DC supplies. So now it's being fed with DC, and that LED, blue LED in here now is fed with 10 milliamps of current, so that has a nice bright light to it, and that should be trouble free for many years. Yeah, it's more of the same, more same. 2 failed caps on this board, cracked solders on these pots, typical Sansui junk. So I'm going to go through and resolder these, and then we'll see what we can do about that. I was getting ready to button this up, ready for testing, and then I realized I forgot to deal with these 2 switches. These 2 switches here, and it's hidden by this block of rubber foam. There's 2 switches under here. Double pull, double throw, push button switches, and they're not latching. So I think they're just poor quality switches. I think I'm going to remove them and see if I might have some replacements here. Maybe if the switch is fine and it just needs lubrication or something, I'll just lubricate it so it starts to latch again. And if not, I'll just replace them. If I have, I think I might have some suitable ones here. So it's going to desolder these and take them out. Okay, so here's the switch. These switches, they don't latch. There is a latching mechanism inside here. You can see it moving around, but it's just, I don't know if it's broken inside or what. But these are kind of difficult to replace because they have a tighter pin spacing than regular, and I do have switches. These are new, but they won't work because they don't have enough plunger length, for one thing. They're not the same. And let's see, here's another one. But these won't work, unfortunately. So we're gonna have to go in and try and repair these, if they are repairable. I don't know if they are or not. If the plastic's broken inside, we're not going to be able to fix it. We'll get it open and we'll see what's inside. Okay, so here we go. So this has a spring clip. You can see this spring clip. It runs from here down across the bottom, up and up to there. And what it does is it holds the lid on. Typically these sit in a rack of it's a steel rack, and they space them out, and the rack holds the body of the switch, and it holds they have fingers that fold over and close down and hold the top down. But we don't have a rack on this one, so we have to remove this spring that they use instead. So we'll just ease this off from the top on both sides and push it down. Okay, and then we need to remove it. Can you see? I hope you can. Be careful it doesn't fly across the room. Remove it from the bottom and put this spring aside, because we're going to need that. Okay. Now there's two ways you can do this. You could just pull the spring back with your fingers and lift the lid off. I'm going to do it a little different. I'm going to pull this clip off. This clip is retaining the spring. Let's pull this off, the plunger and the knob. Wow, it's really on there. You be careful you don't break any plastics here, because there's no replacement parts. Alright, let's remove this clip and then remove the spring. That way I don't have to fight with spring pressure. So let's just remove this and pull it off. And put that back on later. And then the spring, don't let it fly. Okay. Now we're free to just lift the lid off without fighting the spring pressure. Now, let's give it a little pry to start. It might be glued down. I don't know if you can see it here. There's a parting line that runs across here, down and across here. And then in the back, they got some glue, and there's a little tab holding it on this hook. Same on the other side. So we just need to lift the lid off. There we go. And give it some of that. And then we can just remove the lid. Glue's holding. Alright. So there's our little mechanism inside. You can see there's a broken piece of plastic. So this is not looking too promising. Broken piece of plastic. And that broken piece of plastic comes from this channel that provides a place for it to latch to. That plastic's broken and gone. So we can't fix this switch. What do we do? What do we do? If I had similar switches, I could rob parts from it, but I don't even think I have that. So let me pause the camera. Let me dig through my old pile of old switches. Let's see if we can find something that we can use. Yeah, that's unfortunate. For whatever reason, the plastic is... So I'm assuming this one's the same. So let me think about this. Alright, so I searched through my junk switches and I didn't find much suitable. Pretty much the closest one was this one. This one has a different pin spacing and pin diameter. I'd have to re-drill the board. Plus this plunger's too short. This is still too short. A lot of things to consider here. So I think my best solution, actually, well, I had these two. These are the closest replacements I have. Correct pin spacing, correct plunger length, as you can see. But this switch is not latching. This is a momentary switch, And same with this one. This one's not latching either. So they never were latching switches. They would have worked, but no. So I think I'm back to square one with my switches I have here. These. What I'm going to have to do is calculate the distance from here. What I'm going to have to do is, well, let's see here, I'll show you. I might have to cut this off somewhere. Let's put these together and we'll get a mark on this. Line up the pins, okay? And we need to cut this piece so that it fits here. So I'm going to have to cut it probably right about here. And then I'm going to have to drill a hole and put this over the plunger. This plunger sizes are different, right? So this is like, I don't know what that is, a 2 millimeter, this is a 3 millimeter, for example. So the knob won't fit on here. It won't stay on. Will stay on here. So what I'm proposing to do is cut this end off, drill a hole in the center of it, use this as an extension on this switch, and then the knob fits on. And I think that's my only solution at this point to get a working, functioning switch again. Line these up on the bottom. And yeah, we have a problem with height too. This plunger, the center line is higher than this one, so that might cause us a problem. Let me think about this. Might have to do some creative gluing. I could go on AliExpress and look for more switches, but I'm getting a lot of noise on their search results, and it's just clouding my page is filling up with irrelevant hits on their searches. That's the problem with AliExpress, is they throw everything at you and you have to sort through it. There's really no way to filter it down. Most sellers put a jumble of keywords in their heading of their sale so that they get maximum hits on their searches, which doesn't help me. Let me work on this. I'm gonna probably go with this route, probably with this switch, with this plunger cut down and the original knob, and we'll see how that goes. Okay, here's a quick look at what I'm doing. You guys are probably thinking I'm crazy doing this stuff, but this is what we got to do. So I cut off the end of an old switch and I hauled out the inside of it to make a pocket. Just like that. And I'm going to epoxy that on. Now this is what I need to do to get this to simulate this, right? We have, if I line these up, you can see how they start to match. Now, this should be strong enough to withstand just a simple pushing in and out. These are very low, not very strong springs on these switches, so it's pretty easy. And I just used a bit. This is actually a dental bit that I picked up. I picked up a bunch of these a while ago, probably in the 80s. And this one here, this is what I'm using. Jet Beaver Dental Products. What is that? Morrisburg, Ontario. Carbide burrs. Faster, sharper. And these are, like I said, they're for dental in this. That's why I paid for it. $1.99. You won't buy that today. So I'll get through this. I'll get this glued. And then I think it goes like this. And then I'll get this one also snapped off and hogged out, and we'll get this thing going. Okay, so this is the end result. I got the little ends glued on. I used a 2-part epoxy to glue them on initially, and then I wrapped it with floss, and I'm just using a UV cure resin to secure that floss, to wrap it and bond it. Not to really bond it, but to strengthen it, because this is my biggest concern was the white plastic they used on these switches won't stick to a two-part epoxy. It's kind of a polyethylene type plastic, which is kind of a waxy plastic, and it's really difficult to glue to a waxy plastic like that. So that's why I gave it the extra strength of the wrap with the floss and the UV cure resin that will kind of encapsulate it and hold it together, kind of like a band or like a hose clamp. So once I think this is done, so I can install these switches now, and we'll carry on. I think it goes like this. Just going through and doing FM alignment on this thing. This thing's wildly out of tune. Getting incredible gains just from doing the last few adjustments. Problem is, there's a few problems. This is junk, that's one of the problems. But you have to disassemble it to get at the multiplex board. The multiplex board is down. You can't even see it because it's underneath. I don't know if you can see it here. It's right here, underneath this board, which is your input switching in your so you have to remove that board to get at the adjustments, and it was wildly out. I'm just doing the discriminator adjustment now. It was way out. Another adjustment I did was which one was it now? Oh yeah, the IF adjustment was out. Huge gains on that one. So I'm going to keep going on this. I think once I get through the alignment, I think it's going to bring the FM tuner in this right into spec, and it's going to work excellent. But part of the problem I have is this board, this 3767. It references a board 3767, and it tells you to connect to point A, point B, stuff like that stuff. And if I go look on the service manual, it shows a different board, completely different layout. So you have to hunt down the parts you need. This all just takes time. So they must have made a production run change in the middle of running these. These boards are all numbered. This one here, for example, is, I can't even see here. Let's see. This one here is, where's the number? Well, it doesn't really matter. For example, the phono board here. This one's called 3725. They probably use the same board in a lot of different models, and it's just like a module that they plug into another. This board here is probably another one. They probably use it in several models. So this is kind of built with Frankenstein parts, kind of, and they probably changed a lot of things during the production runs. But we're getting through it. Going to finish this FM alignment, and then we'll do some testing. Okay, this thing's playing hardball with me, and it's starting to piss me off. So the problem is I can't get a stereo lock on any of the stations. Stations are coming in loud and clear as far as I can tell. There's no what is it? There's no strength indicator, tuning indicator, strength indicator on the FM. So I don't know how strong the signal is. It just locks in. It has a little LED on the front that says locked. That lights. Okay, that's fine. But I can't get any stereo. So I feed in a 19 kilohertz. I feed in an FM signal that's modulated with 19 kilohertz. Very strong, 100% modulation. I cannot get this to lock. Now, the problem I'm having here is this board does not match the service manual at all. It has the same number, which is, where is it printed? 3767. Okay, this same board's used in a lot of different Sansui receivers, and I went through a bunch of different service manuals for different receivers, and yeah, it comes up the same board. The problem is this board does not match the service manual at all. This is something different. The service manual specifies a Toshiba chip HA1156, I believe, or 57. And this is an HA1196. It's a different beast altogether, different chip. So any of the schematics, nothing matches. On the this chip, I should be able to pick off a signal on pin 16, 76 kilohertz, and I do pick it off on that pin. There is a 76 kilohertz signal on there, and it is adjustable with the trim pot. So you adjust the frequency with the trim pot, and 76 kilohertz is divided down to 19 kilohertz internally, and that's where the 19 kilohertz local pilot signal is coming from. But I can't get this thing to lock. So I'm guessing the chip is bad, or maybe some of these capacitors. I did replace some of the capacitors, but not all of them. And there's a few other ones here I didn't look at all. I didn't check any resistors. There's a styrene capacitor here. They're known to go bad sometimes. So I might just pull, I'm going to pull this board out again, and I'm going to revisit all of these capacitors. And I also have a replacement HA1196 chip. I could pop it in there. If that doesn't work, I'm out of solution. Now I did adjust the discriminator using the distortion method, not the sweep method, and I got some good gains out of this. So I'm assuming this helped, but it's not helping enough. I don't know. If the chip's not bad, then I'm out of solutions. And but then I have to think, how much effort do I want to pour into this piece of crap for fixing the FM that somebody may never use in the future? That's the reality of it. I do want to see it working, but I'm not going to go to the ends of the earth to try and fix this when, like I said, I'm just going to pass this on to a new owner, and they might not even care about FM. They might never turn it on to FM. Not very many of us listen to FM anymore. So, all right, so let me pull this board out and start working on this and see what I can do. I'll let you know. All right, so I'm done with this. What I did is I replaced the remainder. I replaced these four, five actually, 1, 2, 3, 4, 5 caps. I replaced these electrolytics with film. I replaced these electrolytics with film before. These ones aren't the problem. The 3.3 microfarad I replaced. Pulled this 360 picofarad cap out and tested it. It's fine, as far as I can tell. It reads correct value, so I'm going to assume it's fine. And then I popped a new chip in here, and we're going to see if this makes any difference. Actually, I should test these 2 transistors, 3 transistors, 4 transistors, just to make sure that I didn't miss anything. Resistors, I'm assuming, are good. Rarely see a bad resistor, especially in this era. Everything that goes bad with the resistors are the old carbon comp ones from long before this. So I hope this is the problem. I can't imagine anything else going wrong here. The discriminator, when I was doing the adjustments, I was achieving gains as I was adjusting this. So typically, if there's a problem with one or both of these coils, you can make, when you make adjustments, there's no change. There's no gains. There's no results from tweaking these coils. But these ones, as soon as you start turning them, you can see the change on the meter or the scope, and so that tells you that's good, right? These are good, these coils. So I'm not ruling these out, but I'm not assuming they're bad. This, like I said, on the old chip, when I adjusted the local oscillator, this was affecting the frequency. So that part of the chip is working. It just wasn't locking on the stereo signal. And that might be because either the 19 kilohertz isn't getting through to this chip, or there's something that's wrong with it, it's not locking. Alright, so I'm going to put this back in and test it out. I cleaned the back, all nice and sparkly. Okay, I think I made some progress here. I went back and redid the alignment again and again and again. I guess there's some, especially when you're doing the discriminator alignment, you have to go some back and forth a few times. I probably didn't do it enough steps, but right now I'm picking up. It's working on this. It's still a crappy tuner. It's not very good. The biggest problem with this is the muting circuit. The muting circuit is garbage in this thing. I'm almost thinking of just disabling the muting circuit, because it doesn't allow you to tune in weak signals, weak stations, and only the most. Here, I'll do some tweaking here. Quite a strong signal coming in. Very strong, but if I turn this, it kicks out. Yeah, I think I might. I'm wondering, let me try, while you got you here, try turning down the signal strength on the amplitude. I'm negative 72 dBms right now. 82. I'm feeding it a 19 kilohertz pilot tone, quite a loud one too. It's 32 kilohertz deviation. It's a pretty intense tone. Let's turn down the signal strength. It's weaker and weaker. Adjust this muting. Yeah, I think I'm going to leave it somewhere around here. Okay, there's stereo dropped out. And then it completely dies at negative 93 dBm. Let's see here. Let me see if I can get the signal back. Yeah. It's a crappy tuner. That's all it is. So I'm going to leave it alone. It's good enough for me. It's going to work. Connect a good antenna and get stereo signals. I'm done with this. All right, I'm back. Take two. Why is it take two? Well, I had a little mishap here. For whatever reason, I'll put it up in the top corner of the screen. You'll see on the scope. I had a problem with a dead channel on this thing. Now I don't know. I'm 100% sure both channels are working when this started on this thing. During my work on the FM tuner section, somehow I lost a channel. Now I don't know if I had a wire short out at the back here, because I did have speakers connected when I was doing testing. Might have had one wire drape across another, short out the channel and popped it. But for whatever reason I had severe distortion on the channel, and the left channel, and no audio. So I had to take a little time out and replace the SDK chip. That's why these are good actually. It took me like 10 minutes to just pop the old one out and put a new one in. Very easy to do. But again, I don't know if it was my screw up or not. But anyways, we're back on track. So let's do our power test again. Let's see here. Let's turn. I do have a signal going. Let's turn it on and see. I'm feeding it in tape 2. Okay, so there's our tone. Let me turn it on to our load. I think you can see it. And I don't have the scope set properly. Give me a second. Alright, so let's go up to clipping, 1000 hertz tone. I'm liking the repair I did on the volume slider. It's nice and clean now, there's no scratchiness, and it's working great. That was the main, oh there's clipping. That was the main bone of contention with this thing when I first started using it, was the volume pot was so scratchy it was unusable. So let me turn this down. The top trace is left. Turn this down until I get minimal clipping, maximum power. Right there somewhere, I'm going to say. And I'm reading 18.0 volts RMS. Let's start our timer and we'll see how it survives this torture test. Here's our power consumption. 164 watts. Okay, we're already, what, 6 minutes in, and this heatsink's already at 75 degrees Celsius. I'm going to shut this down. It's getting quite hot quite fast. But that's the nature of the beast of this receiver, is built down to a price, has the absolute minimum of everything in it. So I'm not going to torture it any longer. Let's just leave it there for now. I was just looking at the old module. I was going to do some tests on these transistors to see. I don't think anything's bad on this thing. I don't see anything wrong with it. But let me get back to this in a minute. First, I want to do some reduced power tests here. Let's turn up the volume here. Let's do square wave. Wow, it's quite a difference. What is going on with this? Alright, that is the left channel on the stereo, the right channel on the scope. And then they have, ooh, look at that. Shouldn't be getting that. I wonder, that is something with the volume, or the balance pot. I wonder what's going on with that right channel. I don't know. Okay, let's go down in frequency. Huge discrepancy in right and left. That's the bass control cut. That kind of brings it in line. Bass boost. Yeah, there's something wrong with this bass control. Is it plugged in? Yes. I have to go back and explore this. Why we have such a huge difference between one channel. I think I'm pretty sure it's in the tone controls. Okay, bass cut, bass boost. This is the volume. Ah, the old loudness button. Gets you every time. Okay, that makes sense. Still doesn't explain this though. We have little spikes. Okay. Where are we at? We're at 100 hertz. Let's go down. 50 hertz. 40, 30, 20. Nasty switches in this thing. So 20 hertz, got a lot of tilt. Bass cut, bass boost. Okay, let's go back up. One kilohertz. 2, 3, 4, 5. Pretty much lose our square wave around 5 kilohertz, which is kind of not surprising. 6, 7, 8, 9, 10. Yeah. Start to lose frequency response right around 35 kilohertz. It starts dropping off. Alright. I think I've seen enough. Alright, so here's a look at the internal layout of the STK4843. And it's basically for, well, it's, you know, push pull AB class amplifier. Here's our outputs right here and here, and then the drivers. So we could figure out which transistors which. It's not really important. We've got 4 of our output transistors mounted on these aluminum blocks. I think they're aluminum. And then they have on this other heat spreader down here, we have our drivers, 4 drivers, and then all our support circuitry for each channel. The resistors are the black parts. Like here's a resistor here, 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 and here. And some of these are laser trimmed. You can see where they burnt into them with the laser. Right here you can see it. You can't, I'd have to zoom in. And here, so they adjust these in production. So I just want to take a look at some of the diode junctions on some of these transistors. I don't think the outputs were bad because I didn't see any high current. Oh, there's a short. Okay, so between this one and this one we have a short, and then between this one and this one it's open. Okay, no short there. There's a junction. There's another junction. So this transistor's bad right here. Let's put a little X on it. Can't even draw on this. It's covered with some kind of a conformal coating. Alright, let's look at this. This channel's good. So this is the left side. It was the left channel dead, I'm assuming. So yeah, right here we have. Okay, so let's go back and check this driver. Let's go from here. There's a transistor there, or a diode. This diode is right here. This transistor is right here. So let me see. Okay. I think I'm getting this here. Okay. So let's try from here. There's a junction. And let's try from here to here. Another junction. So that transistor's fine. Let's try this one. Same thing. It's probably going to be reverse polarity. It is. Okay, so can't get a read on this one. Okay, there's a junction, and it might be open. I'm not getting a junction there. It's hard to say how this thing failed. I don't see any damage when I take my lens and I look at each one of these little transistor dies. They all look good. You can tell if there was a short circuit, they would look like a little tiny explosion, and there would be a black mark around where the short circuit happened, because there would be a tiny spark, and makes a little black stain. But I don't see anything wrong with any of these on this side. I'm going to check again. But essentially, I suppose if you really wanted to, you could fix this. You'd have to be really desperate to replace this transistor. You could take a surface mount, solder it onto this block, and just attach the wires to the pads on the board here, and you'd probably be back in business. A difficult thing would be is trying to find a transistor with similar characteristics as what's already here. Power transistors not that difficult to match up. You know, you just have to go by current, voltage, and power dissipation. But for the most part, you probably could do it if you were really desperate and wanted to fix one. Maybe that'd be a subject of a future video. When I'm really bored and I have nothing better to do, I can play with one of these things. But for right now, I think I just want to get this turd off my bench and finish this video up so I can get it posted. So I think we'll stop here. And as soon as I shut the camera off, I spot the problem. So I can see it here. Let me see if you can zoom in and we'll see it on this camera. Let me see if I can point it out to you before we lose focus. There we go. Back out a bit. Alright. There's a resistor here. You can see it's black. Let's look at the one on this side. It's all bubbly and burnt. So that's between this pin, I think, and whatever this is. This is the base, I think. Right there, I think. That's our problem. So, yeah. Well, there you have it. I'm wrapping this one up. I'm going to get this off my bench. I got other things I'd like to rather be doing. Put a lot of work into this, and it probably wasn't justified, but I think the video itself will help some people, help some of you out. If a lot of similarities between this model, the 606, and there's a lot of other models, the 505, there's the 411, there's the 610, 611, and 707 liner receivers from Sansui. They're all the similar size, they all have the similar layout, the 3 knobs on the left and the slider on the right. And that kind of suggests to me that it's like a carbon copy of each other. They just put different, maybe add features on one and take features away on another. And yeah, these things, if you have one, it probably belongs in a electronics recycling bin. But this one we're going to have and listen to and see how it sounds. If it redeems itself, I might just pass it on to a new owner, and hopefully they'd be happy with that. So that's it for this one. Thanks for watching, and lots more coming up, so take care, and we'll see you on the next one.